So what I wanted to go over real fast before we finish our notes is if for some reason on your SSO portal, you don't see this RTI scheduler, you can just go to rtischeduler.com to get to where you sign. This is where you sign up for tutorials. I'm still getting lots of questions about tutorials and when I have them. So if you have the icon here, click it, great, and you'll go to and you'll be able to see your calendar and sign up for tutorial sessions. I did add the link on our homepage on Canvas in case you don't have that icon for whatever reason. I put here, I updated our little message here to talk about tutorials first. So my tutorials are Thursday and Friday. Every teacher has 2 days a week of tutorials. So mine are Thursday, Friday, and it's the second half of Lightning Lunch. So I have my lunchtime first and then my tutorial session. Okay, here's that link that I just said. If for some reason you don't see it in SSO portal, you can click it here. Once you get there, I would just bookmark it. Then you don't have to go through anywhere first. You can just go to that bookmarked page. If you need tutorials another day, so let's say we have a test on a Thursday. My tutorial's not till Thursday. And you're like, well, I wish I could go to tutorials before the test that week. I can help you get signed up in another Algebra 2 teachers tutorial that does have them Tuesday or Wednesday. If you have questions you want to ask about the review or just general questions about whatever the topic is or an assignment, okay? So you can sign up for other Algebra 2 teachers tutorials when I'm not available, okay? Depending on their settings, it may be set to where only their students can see their schedule and sign up. So if that's the case, if you don't see an Algebra 2 teacher available on a Tuesday or a Thursday, I can get you signed up. You just need to get with me and I'll get you enrolled in their tutorial and tell you where to go, who you're going to, and what room. So you can get the help you need other than on Thursday or Friday. Now, if it's just a general week, there's not a test or a quiz or something, just wait till my tutorials, okay? Be patient. I know it's the end of the week and I'm sorry I didn't pick those days. They were given to me. But if it is something like you need in earlier, there are Tuesday and Wednesdays available with other Algebra 2 teachers, and they would be able to answer your questions as well. There are no Algebra 2 tutorial options on Mondays. We have our team planning meeting on Mondays, so nobody is available Monday for Algebra 2. But I can help you on a Tuesday or Wednesday get signed up with someone else if you can't wait till my Thursday for Friday. Does that make sense? Okay, so I just wanted to make that clear about tutorials. The other thing is our quizzes from yesterday. If you have not done that yet, don't forget it is due tomorrow. You will have a little bit of class time tomorrow. Tomorrow is just a work day. We've been taking notes. This is our 4th day of notes on parent functions. And so we're going to just practice tomorrow what we've been learning over the past 4 days. So it's a practice day. You're going to have an assignment in Delta Math. But if you need to finish the quizzes first and then start the Delta Math, you'll be allowed to do that. But just don't forget that that quizzes is due by tomorrow. And you have 3 attempts at it. And I'll take the best of the 3 attempts. So if you tried it once and you didn't get 100, you can still go back in and try again before midnight tomorrow and get a higher grade. I'm talking about the matching quizzes from yesterday. When we did it as a group activity in teams, that was not for a grade, but then I told you it's assigned to you individually to go in and do it, and you can use your notes if you need to, and you have 3 attempts to get the highest grade you can, and that's due tomorrow. No, but it's all in your notes. It's matching. It's the exact one we did as the warm up with the team yesterday. And you can use your notes. All right, so yesterday in our notes, we did a little recap, a domain and range refresher, and we started going through all of our parent functions and filling in the domain and range. So let me see where we left off in here. It's got rational, quadratic, square root. And we said cube and cube root were both all reals. Oh, did we get through them all? Awesome. Okay, so we finished domain and range for all of them. I think maybe the bell was ringing right when we were doing log. So if you did not get the log domain and range copied down, make sure you do get that. We talked about how this dashed red line here stopped us from going any further left. So that restricted our domain. So our domain was 0 to infinity, and it did not include the 0. But the range, it goes down forever, and as it's going right, it's going up forever. So the range was all real numbers. Okay, all right, so we have all of the domains and ranges. That's great. So now we just need to add that last box for all of these says other key features. So domain and range are a key feature. X-intercepts and Y-intercepts, those are key features, but we have all of those filled out already. We did the X and Y-intercepts day 1, and then we did the domains and ranges yesterday. So now some of these have other key features. They're not all the same. That's why I just put other instead of listing specific things out, because it varies depending on which function we're looking at, what their other key features are. Okay, so since we're back here talking about logs, I'm going to go ahead and just start with logs. Okay, we have this dashed vertical line that we sketched in here to give us a visual showing that this curve does not ever touch that axis. That dashed vertical line has a special name. And I think I mentioned it earlier in our notes, but we didn't write it down. Does anybody remember what that's called? That line that you approach but never touch? No? Actually, before I put it here in other key features, let's write that definition. So flip back over to the back where we did our little refresher on domain and range. And we're going to add one more definition back here. So on the back, you should have a warm-up done from last week and then the little domain range recap. Okay, and now we're going to add this definition. Asymptote is ASYMP TOTE. That's asymptote. An asymptote is a line the graph approaches but never reaches. Okay, its job is just to guide the function. So if it guides the function's end behavior, or it guides the behavior wherever that asymptote is. I guess I should put an S there. It guides the function. Okay, so there's an asymptote. Now, that line, it can be vertical, it can be horizontal, and it actually can just be, it could be any line. We're only going to look at vertical and horizontal, but technically there's other asymptotes as well. So let's go back down there to logs now. For logs, what type of line is this dashed line? It's an asymptote, but what direction is the line going? It's vertical, right? So this would be called a vertical asymptote. So on my other key features, I'm going to say there is a vertical asymptote. Now I'm going to say where it is. It's at, now a vertical line crosses what axis? What axis am I crossing if I have a vertical line anywhere? Crossing the x-axis. So remember, vertical lines are written as x equals, and then wherever it is they're crossing. This one is crossing at 0. So it's x equals 0. It is the y-intercept. Okay, so the y-intercept is a vertical asymptote here. Now, other key features would be things like maximums or minimums of your graph, or a vertex, or maybe a line of an axis of symmetry. This function doesn't have any of those. Remember, a vertex is where a graph changes behavior, like it goes from increasing to decreasing or decreasing to increasing, like it turns. Okay, this graph, it veers off to the right, but if we trace it, it's always increasing, isn't it? Keeps increasing forever. So there's no change in behavior or change in direction. So there's no vertex here. Is there a maximum to this graph? Is there like a high point? No, that arrow means it goes on forever. So there's no maximum. It keeps going and going and going, up, up, up. Same thing with the low. There is no minimum here. There's no low point. It goes down forever. Okay, so there's no maximum, there's no minimum, there's no vertex, and this graph is not symmetrical. Okay, so there's no other key features we need to list besides that asymptote for this function. Okay, so let's look at exponential. So exponential, what's different about the dashed line here? It's along the x-axis, so it's a horizontal line. So we have a horizontal asymptote. Now, a vertical line, I said, was x equals a number because you cross the x-axis. A horizontal line, we talked about this when we did the constant function. It's y equals a number for a horizontal line, right? And this is crossing the y-axis at 0. So this is a horizontal asymptote at y equals 0. This graph, it doesn't matter if we look at the base 2 or the natural base e or the base 10. Remember when I showed you the different base values, we said that base could be anything, but it didn't change where the asymptote was. It didn't change where the y-intercept was, and it didn't change the direction of the graph, the general shape of the graph. So it doesn't matter which one of these you follow, there's no vertex, there's no maximum, there's no minimum. Okay, so there's no, and this is not symmetrical either. Okay, so no other key features we need to list here. We've got our x and y-intercept, or lack thereof for x-intercept. We've got our asymptote, we've got our domain and range. Now, let me actually, while we're on this page, I showed you B being different base values here in those 3 colors. I think we ran out of time when I wanted to show you that with log, and I only showed you the B value, the base, being a 2. So I'm actually going to go ahead and add on here the base 10 or the base E to show you what that looks like in the log function. So let me switch colors here. I think I did a base 10 in green. So if I do my log of x and I do not write a base, I don't put a subscript after the G, that is an understood base 10, because base 10 is what we refer to as our common log. Okay, and I'm going to show this to you in Desmos since you're not familiar with logs. Let me give you a good visual so you can see how it changes. So if I want a log with a base value of 2, like the one that I originally graphed for you, I would need to go to functions and scroll down to calculus here, and I can see log, and I can see log with a subscript. So I would click the one with the subscript, and I would put my base 2 there. And there's that log base 2 of x that we already graphed. And I think I graphed it in black on our notes. Now, if we just type in log with no base, you can see how it's different there. So it still has the same intercept, the same x-intercept, and it still has the same vertical asymptote, and it's still the same general shape, increasing left to right forever. Okay, it's just doing it at a much slower rate. It's increasing much slower. Do you see that? Now, if I put in the natural base, I told you that E is what is called the natural base for log and exponential. And E is actually a number, just like pi is a number. E is a number. I don't know why that didn't copy the base. Let me try that again. Change that to an E. There we go. You can see the natural base there would be in between, just like on the exponential. The natural base was between a base 2 and base 10 because E is like 2.7 something, 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 right? So, but it's still same x-intercept, same vertical asymptote, same general shape, okay? What I want to tell you, though, is when you have a natural base on your log, this is not actually how we write it or type it. If when you go to functions, you may have seen next to log, you have log, and then you have ln. That is a representative for natural log. So if you have if your base is E, if you're doing a natural log, you don't have to write log base E, you just have to write ln. And you can see, let me put that in a different color here. So you can see the orange and the blue. If I turn the orange off, the blue is right under it. Because ln of x or log base E of x, those mean the exact same thing. And this is much quicker to write. Okay, so we call that our natural log. So I just wanted to point that out to you. So let me add that to this graph. So the base 10, the common log, it would have crossed way over here. So it would look like that. And then the natural log would just be ln of x that is your base E, be at 2.7-ish, should be at 1. So it'd be right there in between them. Okay, so just so you have a slight understanding that for exponential and logs, your base value can change, but it does not change your key features. Your domain and range did not change. Your x or y intercept did not change. Your vertical asymptote did not change. So it doesn't matter what that base is. If you have any log of x, these key features hold. Same thing with exponential. It doesn't matter what that base value is, okay? As long as it's not 0, it can't be 0. But any base value is going to give us the same key features. We're still going to have this horizontal asymptote. We're still going to have the same domain and range. We're still going to have the same y-intercept. Does that make sense? Okay. All right, so we got those asymptotes. So now let's keep going, working our way backward here. And let's see if there's any other key features we need to list for cube or cubic. So with the cube and cubic, are there any asymptotes? No. Is there a vertex? If I trace my graph and I sketch it, do I ever change directions? No, it's always increasing, right? So there's no vertex. Is there a maximum or a minimum? Is there like a highest point of the graph or a lowest point? No. Okay, because it goes up forever, it goes down forever, and there was no change in direction. So there's no max or min. Okay, so none of those key features need to be listed, and it's not symmetric. It does not have line symmetry. Okay, so there's not an axis of symmetry. Okay, but what happens in the middle at 0, 0, you'll notice for both the cube root and for the cube on both of these, do you see how the shape of the graph slightly changes? Because it's kind of concave this way and then it's concave this, so it's kind of concave down, concave up. It's like the direction that the curve bows out in a different direction, it changes there. Okay, a lot of people mistake that for a vertex. They want to say, oh, the graph changed there. It did not change behavior or direction though. So it is not a vertex. It has a special name. It is what we call a point of inflection. So both the cube and the cubic have a point of inflection. At the origin. But there's no vertex, there's no max or min, there's no line of symmetry, there's no asymptote, nothing else about those for other key features. Feel okay about cube and cube root? Guys, put your phones away. Get off your phone, put it away. All right, the next page, working our way back, we've got square root and quadratic. Okay, so let's actually do quadratic first. So on the quadratic, is there a change in direction or a behavior of the graph? If I trace this, I'm coming over it, I'm decreasing, 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 and then I get to here and all of a sudden I'm increasing. That's a change in behavior of our graph. So that means that that point at 0, 0 is a what? What's that called? A vertex. So this one does have a vertex at the origin. Now, when you have a vertex, when you have a change in behavior, you're going to have a maximum or a minimum point. It's either going to be a high point or a low point. In this case, it's a low point, right? It's a minimum. Okay, now our minimums and maximums can be classified as relative or absolute. We'll get into that more in depth later. I'm going to go ahead and label this as absolute. What that means is this is the lowest point anywhere on the graph. It is absolutely the lowest point anywhere. It doesn't turn again and come back and get lower elsewhere. Okay, so that's what absolute tells us. So I'm going to say that that is an absolute minimum. Are there any asymptotes on this graph? Okay, what about symmetry? Is this graph symmetrical? Yeah, where could I fold it to see that it's symmetrical? If I folded it on the y-axis, all of these points on the left and right would line up exactly the same as each other. So this has line symmetry, okay, and the line of symmetry, which we call the axis of symmetry, is the y-axis, that vertical line there. So you may remember this abbreviation, you may not, but it's AOS for axis of symmetry. You can put that off to the side if you don't know or remember what that means. Axis of symmetry. So there's an AOS, and we said it's the y-axis, which is a vertical line. So vertical lines are x equals a number, and in this case, it's at 0. So x equals 0 is our axis of symmetry. That's where we could fold that graph and everything would align on the left and right. Now, does the square root function have any of those same attributes or features? What do y'all think? Is there a change in direction here? Does the graph ever like change from decreasing to increasing or increasing to decreasing? No, if I trace it, it's always increasing. So there's no vertex. There's no asymptote. This one is not symmetrical. But what does it have that we listed up there? It has a minimum. Even though this is not a vertex, that doesn't mean it's not a minimum or a maximum value. You can have a maximum and a minimum not be a vertex. Okay, this is just an endpoint of our graph, but it is the minimum point of the graph. So this does have an absolute minimum. At the origin, 0, 0. If you want to make a note that it is not a vertex, you can add that, or just understand we didn't write vertex because it's not a vertex. Okay, so that point at the origin is a minimum, but it's not a vertex because there was not a change in direction there. All right. Rational. No vertices. What's the plural of vertex? No vertices. Neither of these curves change direction. It's not symmetric over one axis. This does have a different type of symmetry, but we're not going to get into it right now. Y'all don't know about it yet. There's no maximum or minimum. This goes down forever and up forever. But what does this one have? It has asymptotes. It has both vertical and horizontal. Remember, log only had vertical and exponential only had horizontal. This one has both. So there is a horizontal asymptote. And from here on out, you will see me abbreviate that HA, horizontal asymptote. And the horizontal asymptote that was left to right, that is a horizontal line is y equals. So this is at y equals 0. It is the x-axis. And then there is a vertical asymptote. You'll see me abbreviate it as VA at x equals 0. It is the y-axis. So both axes are asymptotes in the rational parent function. So those are key features of that function. Cool? All right, then up here with absolute value. Should look familiar. It's going to have the same key features as which function? Quadratic. We said yesterday when we were doing domain and range, we said this had the same domain and range as quadratic because it goes left and right and up forever and has the same bottom point at the origin. It has the same intercepts and it also has the same other key features. There is also a vertex, which is an absolute minimum at the origin. And there is a line of symmetry or an axis of symmetry on the y-axis, which is x equals 0. So absolute value and quadratic had all the same key features. same domain and range, same x and y intercept, and same vertex, absolute min, and axis of symmetry. Very similar graphs. The absolute value is straight lines, though, has a point where it turns. Okay, the quadratic is a curve. So it's the V versus the U shape, but the features are the same. All right, and then back to the very front of our packet, there's nothing special, nothing extra we need to add to linear. There is no asymptote, no max or min, no vertex, no, it's not symmetric about the X or Y axis, okay? So there's nothing extra we need to add down here for key features of linear. If you want to make a note that there's nothing to add, you can just like do a circle with a line through it or something so you don't think you accidentally left it blank. There's nothing for us to add there. We have our X and Y intercept. We know our domain and range. That's it for linear. Okay, constant, that's really the same thing. The only thing special about it is that it is a horizontal line, but I already wrote that up here. So for mine, because mine is electronic and I can do this, I'm just going to move that to other key features, but you don't have to. If you just wrote horizontal line up there, that's fine. There's nothing else there's no asymptotes, there's no vertex, there's no max or min. Okay, there's nothing extra to write there. Good? All right, so we finally finished up that packet completely on parent functions. This is something you're going to want to keep all year. You will likely refer back to this often because we're going to do units over a lot of these different types of functions. We're going to have a whole unit about rational, a whole unit about quadratic, a whole unit about exponential and log, okay? And you can refer back to all of this key information about the parent function. Remember, the parent function, this is how it starts, okay? And then we can adapt it from there later, okay? We have a formative assessment in AWARE. Let me see if we still have plenty of time. We've got 14 minutes. So we're going to do the formative assessment in AWARE. Remember, a formative is just, what do you know at this point? I am not grading you. Okay, it is not going in the grade book. It is low stakes. Okay, but we're going to do it without looking at anybody else's work, without looking things up, and without looking at our notes. Okay, so go ahead and put your notes away and get your laptops out and go to AWARE, and it's a 5-question formative. It'll take you anywhere from 5 to 10 minutes. Okay. And we're just going to see where we're at with parent functions at this point. Okay, so for those watching this as a recording, I'm going to stop the recording. If you have not done the formative, you can go log into AWARE and do the formative as well. Let me turn this off.